All right, so we have now written down our period, we've written down our phase shift, we've written down our vertical shift, and let's go ahead and do our new tick marks too. Let's make sure we have that down. All right, so for our new tick marks, we said it was 0, pi, 2 pi, 3 pi, and 4 pi. So that's our new tick marks. So again, just like we did before with our sine function, our cosine function, first thing it's going to do is go ahead and label the graph. So I'm going to do this part. And I'm going to do this side over here. So we have pi, 2 pi, 3 pi, and 4 pi. And I'm also going to put a negative pi over here because, oh no, sorry, wrong. We don't need that part because we are not going to the left. We're going to the right. So if the pattern continues on, that's 1, 2, 3, 4. So the next one's going to be 5 pi. So we're going to use that because we're going to have to move everything to the right. So I'm just throwing that on there now. And then here we know we're going to have to move everything up to. So we're going to start off with 1 there. I'm going to say this is 1, and we're going to have to move everything up 2. So I'm going to go ahead and put all that on here now. And then I'm also putting -1 down here. Okay, so I'm going to start off again just so that we can remember this part here. We're going to start off with our sine function. I'm going to do that in because remember, sine and cosecant are inverses of each other. So I'm going to do the sine graph first because that will help you remember where everything should go and don't have to guess about stuff. Or if you remember your properties, it'll make it even easier too. So I'm going to do this part. I'm going to just do from 0 to 4 pi because the period is 4 pi. So I'm going to put our dotted line here. And remember, make it curvy, not like hard and harsh and all that good stuff. All that stuff. All right, so we also know when it comes to, I'm going to go ahead and do the blue part, which is actually going to be the original cosecant graph. So if that happens, a cosecant, remember, where sine is equal to 0 is actually an asymptote. So it's an asymptote there, an asymptote here, an asymptote here. All right. So with this, if we are looking at just this part here, we should be able to see, okay, well, originally the graph would come here at this part in blue, and then it would go up like this, and then this part would go up like this originally, and this would go down, and then this would go down originally. And again, remember, we don't do the solid graph until the end, so I'm putting dots here so that we can actually see what's happening next and all that good stuff. Okay, so we have the sine graph because sine and cosecant are the same, or like not the same, but they are inverses of each other, but they use the sine graph to help you with the cosecant graph. So I'm going to go ahead and get rid of the sine graph here. We don't need that right now anymore. All right, so we have all this going on. Now, with it, we have to go ahead and still move everything up to, we said to do the vertical shift and, the phase shift. And so here, so let me do this. Number 2 was do the parent graph. And in this case, this was our cosecant theta graph. Say y equals. Okay, so now after we did that part, we said, okay, do the amplitude. In this case, there was no amplitude. So we go to a vertical shift. And 9 times out of 10, there won't be an amplitude for cosecant and secant. There might be one for tangent and cotangent, but not for secant and cosecant. But vertical shift means we're going to go up 2. So we're going to take every point up 2. And really, on this part, the only thing that really needs to move is this point, and this point. Because that's really the only points that we have on the graph. So hard. Oh, that's so hard. So here, we're going here. And we're going to go up 1, 2. And then here we're going to go up 2 from this point. So 1, 2. All right, so if we were to do the vertical shift and show what it looks like, it would go up like this for this part here, and it will go up for this part here. And this one still will go down, so it doesn't change. We haven't flipped anything. Now, again, with this, like I've said before, when it came to sine and cosine, the best thing to do is go ahead and use different colors. So that way you can see what was the last one you just did, and then be able to do the new one. So here, so far, we actually have dealt with our period. We've dealt with the vertical shift, and the last thing is just going to be your phase shift. And let me do a different color. Let's do black. So the last part is just our phase shift, which means we're going pi over 2, but we're going to the right. So that means we're going over this direction. But hopefully you still remember from when it came to all the tables and stuff we've done. We know pi over 2 are like the pieces. There's like the piece right here between 0 and pi. And then there's another pi over 2. This is 3 pi over 2 right here. And then another pi over 2 is 5 pi over 2. So all the pi over 2s are really between the pi's. So for this problem, we said we're going to the right pi over 2. So here that means, we take the red part, which is our vertical shift, and we move it over pi over 2 to the right. So that means we're going to just move this over to this point. So that moved over kind of like a half. Now, that means if this moved over from red to the black, moved over just like a half, that means this red dot is going to move over a half. So we should have something like right here, which is like 7 pi over 2. So we're moving that over a half. Okay, so far not bad. Now, with that, we're moving those dots over, but we also have to move our asymptotes over pi over 2, or consider like a half. So here, that means the blue part right here needs to move over a half. This blue line needs to move over a half. And this blue line needs to move over a half. So it's about like right here. So this would be 9 pi over 2. So that will move over here. All right, so now everything just looks kind of funky, right? Just weird and just crazy. So with that happening, I'm going to go ahead and redraw this really quickly. Let me do it in black, everything in black. So I'm redrawing all of this over. And if you need to, that's perfectly fine. If you need to do a new graph for each one of these, for each transformation, that's fine. I don't mind you doing that. We have enough graph paper. We have enough. So we can do that. If you want to do that, if it looks too messy for you, that is perfectly fine. Just let me know that's what you want to do, and that's fine. But don't quit on me. That's the only thing I would say is don't quit. So here, again, just matching up with what we have. And this is 1, 2, 3. So asymptotes are here at the pi's, pi over 2's for this part. So remember, everything just moved over a half. So not pi over 2's. Everything just moved over a half. So 5 pi over 2. And then it should be at 9 pi over 2. Oh, sorry guys. Don't need that part. Oh, no, stop it. Hi, sorry about that. Just popped up and then it went go away. So now it's gone. All right, so let's keep going now. For some reason, I don't know why that happened. All right, so here we already did our asymptotes. So at 3 pi over 2, we move that dot over to 3. So 3 pi over 2 is here. And if you look back up here also for this other dot was 7 pi over 2. And it's at 1. And then here this just goes up. And we're doing solid because it's the final graph. And then we come down here. All right, now I know that's a lot of information there. I know that we have to do some work and everything of that sort. But with that, just know that it takes time, but you have to just take your time through it, and it's going to be okay. It will be okay. And we'll do more practice, and we'll work on this, and then you have it on your test. Yay!